So for our fourth method, it involves the case of an exponential equation leading to a quadratic equation. So to better have a grasp of this, let's consider this example. 9 raised to x minus 5 times 3 raised to x plus 6 is equal to 0. So our goal here is to write one base. So basically in here it is the first term as the square of the other base. Okay? So we know that 9 can be expressed as 3 squared. So we have 3 squared raised to x minus 5 times 3 raised to x plus 6 is equal to 0. Basically, 3 squared raised to x can also be expressed as 3 raised to x squared minus 5 times 3 raised to x plus 6 is equal to 0. If we will notice, this can be considered as a quadratic form. However, it looks complicated. But if we let u be equal to 3 raised to x, we can form a quadratic trinomial. U squared minus 5u plus 6 is equal to 0. Factoring this will lead to u minus 3 times u minus 2. And basically, they are just equal to 3 and 2. Recall that earlier we let u be equal to 3 raised to x. That's why 3 raised to x is also equal to 3 and 2. Now, we need to solve for the value of x. We have two solutions for this. For the first one, we know that any number raised to 1 is just itself. Simply put, x is equal to 1. For the second solution, we can just use the definition of a logarithmic equation to find the value of x. That is, x is equal to the logarithm of 2 to the base 3. That's why our solution set for this particular example is 1 and the logarithm of 2 to the base 3. Proceeding to the example 4.2, we need to solve x in 25 raised to x minus 5 raised to x plus 1 plus 4 is equal to 0. So again and again, 25 can be expressed as the square of 5 raised to x minus 5 raised to x times 5 raised to 1 plus 4 is equals to 0. So particularly in this one, we know that this term and this term is just the same because knowing that they have the same base, then we can simply add their exponents, which results to this. So they are just equivalent. Okay? Now, focusing on this, we can interchange the position of x and 2 because that will not affect the value. Uh, Actually, they will just be the same. So we have 5 raised to x squared minus 5 from here times 5 raised to x plus 4 is equal to 0. Again, we can let u be equal to 5 raised to x to have u squared minus 5u plus 4 is equal to 0. And then we can factor it out as u minus 4 times u minus 1, giving us the following values. U is equal to 4 and u is equal to 1. Recall again that u is let as 5 raised to x earlier. That's why 5 raised to x is equals to 4 and 5 raised to x is equal to 1. For the first solution, we can again use the definition of a logarithmic equation. That is, x is equal to the logarithm of 4 to the base 5. While for the second solution, we know that any number raised to 0 is equal to 1. So we have these values of x, and we have this solution set, which is 0 and the logarithm of 4 to the base 5. Let's proceed to the third example. Find x in e raised to 2x minus 7e raised to x plus 10 is equal to 0. So for this one, it is quite obvious. So we can just express this as e raised to x squared in here minus 7 e raised to x plus 10 is equal to 0, wherein we may let u be equal to e raised to x, giving us u squared minus 7u plus 10. This can be factored out as u minus 5 times u minus 2. And equating both of this to 0 will give us 5 and 2. Now, e raised to x is equal to 5 and e raised to x is equal to 2. Taking the natural logarithm of this, we will get x is equal to the natural logarithm of 5 and x is equal to the natural logarithm of 2. So we can just revisit the previous methods that we applied for the different cases of equations of exponential or in exponential form, okay? For us to be reminded how we solve this. Therefore, our solution set will be composed of the elements, the natural logarithm of 2, and the natural logarithm of 5. Now, we can proceed to the fourth section of our topic, the real-life applications of exponential equations. So in reality, exponential equations are used in predicting the population of humans, population of bees, bacteria, and such. Also for solving of compound interest, for observing bacterial growth, and identifying the half-life of radioactive substances. So take note, class, that another relatable example of application of exponential equation is the customer feedback. No? For example, I am a customer of a laundry detergent, which we will call brand X. And I told to my class of 28 students that this product is not good, it's not effective, this is not worth your money. No? And if it happens that each of my 28 students shared that feedback, shared that piece of information to other set of 28 different individuals, we can see that that piece of information is being shared exponentially. It reaches a number of people on an exponential manner, right? So that is one of the relevant examples of how exponential equations apply to real life. So another is the aging of human beings and the food degradation. So specifically, we have the so-called exponential growth and exponential decay using this formula. A is equal to P naught times E raised to RT, wherein A is the value or amount after a certain period. So this amount can be, or this variable can be population, grams, number of Facebook followers, etc. As well as for the P naught or the initial value. Then we have the R for the rate of change and T for the time. So for exponential growth, note class that the rate is greater than zero or positive. That's why it is increasing exponentially. For exponential decay, the rate is negative or less than zero. That's why it is decreasing exponentially. So to understand this, we have to consider this problem in the early stages of the COVID-19 pandemic in the Philippines, we can clearly see how relevant exponential equations are in our present situation. There were 50 individuals affected, but each day the number rose by 5%. After how many days would about 300 individuals be infected? So, class, to better solve this or to have a good approach in solving a word problem, I am introducing you the GAFSA method, wherein each letter of this acronym correspond to the following: given, asked, formula, solution, and answer. So let's do this. What are the given? So the given and asked can simultaneously be identified. So first, we have the amount of individuals or the population of individuals after a certain period of time, 300. We have the initial population, 50 individuals. We have the rate, which is 5%, which is which in our case will be converted to decimal for easier calculation, 0.05, and we have the component which is being asked, the time in days. So observe class that from an initial amount or initial value of 50, it became 300, meaning there is an increase of value. That's why this problem can be categorized as an exponential growth problem. So let's proceed to the next letter F for formula, which I already gave you earlier. Now we can also proceed to the solution wherein we can safely substitute the values we obtained earlier to the formula. So A is 300, the initial population is 50, the rate is 0.05. So we will have 300 is equal to 50 e raised to 0.05 times t. So dividing both sides of the equation by 6 or by 50, we will have 6 is equal to e raised to 0.05 0.05 t. So we can take the natural logarithm of both sides and apply the inverse property of natural logarithms, which I already showed you earlier how to do. So we will get now the natural logarithm of 6 is equal to 0.05 t. Now we can identify the value of t by dividing both sides of the equation by 0.05, giving us this answer. And if we use calculator, we will identify that the natural logarithm of 6 all over 0.05 is equal to 36. For your answer, I just want to see in your graded exercise the statement form of the question in the problem. Of course, with your final answer, because basically it is the role it plays. So, just like this, it will be written in this way. After approximately 36 days, it is expected that about 300 individuals would be infected. But take note, class, that we are not allowing you to use calculators. So, the final answer in your graded exercise will be this, okay? So, after ln over 6, natural logarithm of 6 all over 0.05 days, it is expected that about 300 individuals would be infected. So that is already accepted as the final answer. Okay, class? You don't need to use calculators to solve for this, at least for our graded exercise. And take note, class, that you don't have to use the word approximately when you will be using this answer, because we just use this term when we are using a calculator. Okay, let's try another problem. Hospitals used radioactive substance iodine 131 in their researches. It is utilized in locating brain tumors and in measuring heart, liver, and thyroid activity. So we can see how exponential equations apply to the field of medicine and chemistry. So a hospital purchased 40 grams of the substance. 8 days later, a doctor found that only 20 grams remained. What is its decay rate? So obviously, the problem is asking us the decay rate. So we can also deduce this from um, obtaining the given and ask. So we have 20 grams as the amount after a certain period of time, which is 8 days. And we have the initial amount of this radioactive substance as 40 grams. So from 40 grams, it decreased from 20 grams, which clearly indicates that it is an exponential decay problem. So let's proceed to the formula, which is this. And by substituting the given values, we will get the following. 20 is equal to 40 e raised to r times 8. So dividing both sides by 40, we will have 20 divided by 40 is equal to 1 half. In decimal, it's 0.5 is equal to e raised to 8r. So again, since we're dealing with Euler's constant e, we have to take the natural logarithm of both sides and apply the inverse property of natural logarithms in this. side of the equation, giving us the natural logarithm of 0.5 is equal to 8r. Now, we have to divide both sides of the equation by 8. And if we use our calculators, we will get a negative value, which agrees to our theory earlier that when it comes to exponential decay, our rate must be negative. So we have this rate, but if we convert it to percent, we will have negative 8.66%. However, in your answer, in your graded exercise, I am expecting that your final answer will just be this, okay? So the decay rate is approximately 8.66%. This is correct, but it can also be expressed as the rate is approximately negative 8.66%. So class, take note that if you use or already use the term decay in your statement, you don't have to indicate the negative sign. But if you're only using the term rate, it is important that you have to indicate the negative sign. But in your problem, in the context of your problem in your graded exercise, I'm just expecting your answer to be the decay rate is r is equal to the natural logarithm of 0.5 over 8. Okay? Nothing more, nothing less. Use the term decay rate without any sign and without the word approximately. Okay? The decay rate is natural logarithm of 0.5 over 8. Or if you want, include the r. R is equal to natural logarithm of 0.5 over 8. And that's it for our fourth section. Of course, as I keep mentioning, you will have an assessment in form of graded exercise regarding exponential equations, wherein you have to answer the following completely and accurately in one whole sheet of paper. Completely means you are able to follow the step-by-step process in solving an exponential equation, regardless of the method used. And in terms of solving problems, I need to see the GAFSA method, okay? I need to see that you state the given, the ask, the formula, the solution, and the final answer, okay? By that, if your answers are not correct but you did the process completely, partial points will be credited. But of course, it will be better and it will be best if you answered this graded exercise accurately, since it gauge your learning when it comes to exponential equations. So your outputs will be collected and submitted in your next meeting. So class, please answer this because this will be graded and recorded. For item 1, which is for 7 points, solve for the value of x in 4 plus 2 raised to x times x minus 3 is equal to 20. And number 2, suppose a Facebook page is created having 400 followers on the first day. The creator wants to achieve a total of 49,600 followers after 10 days. So medyo madami-dami to. So what must be the rate of its popularity expansion? Ano kaya yung rate niya, no? So everything is given to you naman. I just need to see your complete and accurate solution. So for item number 2, it is worth 8 points. So class, if you have questions about our topic for today, just reach me out through or via email. And if you have clarifications regarding the instruction of your graded exercise, you can also email me. So thank you and good luck.